This is a demonstration of deploying FileNet Content Services container in AWS. We will be leveraging these services within AWS for our deployment configurations. First is EKS, which is the Kubernetes Container Service. EC2 is the compute instances that we will be using for our worker nodes for EKS. The ECR, which is the container registries to store our Docker containers. RDS Oracle is the database that we'll be using. S3 and EFS are our storage devices that we'll be using for CPE, as well as other storages that we need from a FileNet Content Services perspective. And lastly, ALB is the load balancers that we'll be using for load balancing our traffics to our FileNet containers. Let's go take a look at what our environment looks like. First, you can see here is our EKS cluster that is created. What sits behind this EKS cluster is the EC2 instances that makes up of our worker nodes. As you can see here, we have 3 worker nodes that spans across 3 AZs. These worker nodes are also fronted by a load balancer for our workload to get access from a client perspective. And so there are 2 load balancers or application load balancers that has been created for CPE and Navigator. Next, we'll look at the container registry where I have pushed the FileNet containers into ECR, or the container registry, so that we can easily pull these images into our EKS cluster as we deploy our FileNet workload. RDS Oracle is the database that I'm using within this environment. And so CPE and Navigator are going to be using this Oracle database as their backend database repository. The 2 storage that I'll be using is, of course, AWS 3, which is an object storage for that is compatible with FileNet Content Platform Engine. And lastly, the Elastic File System has 2 purposes. First, it will be used for our content storage as a secondary option to store our content for Content Platform Engine. And the second purpose is to also store our configurations that are needed for our FileNet containers. So let's take a look at our EKS clusters. There are 2 ways for us to be able to look at and manage the EKS clusters. First is through the command line. So I can access my EKS cluster through the kubectl command, which is the Kubernetes CLI that are typically used. As you can see here, as I mentioned, there was 3 worker nodes that are comprised of this EKS clusters, and you'll be able to see that there are 3 worker nodes. Another method for us to be able to see the Kubernetes clusters and manage that a different way is through deploying a Kubernetes dashboard. And in this environment, I have already deployed the Kubernetes dashboard, so I actually have it up and running right now. As you can see here, this is the Kubernetes dashboard that I have deployed and I'm accessing within this EKS cluster. And the information from this dashboard shows the exact same information that we saw from the kubectl command line. So there are 3 worker nodes that comprises of this EKS clusters. Next, I have already deployed CPE, and so let's go get a look at our deployments. As you can see here, the CPE is already deployed. It has 2 replicas. And if we also go to the dashboard, we should also be seeing the exact same information, which is this CPE deployment that comprises of 2 replicas. And then if we drill down into this deployment, we will see that there are two services that are attached to this deployment. One is an internal service that will be used for Navigator. The second one is for a client traffic endpoint that we will tie our application load balancer to. So if we go back to our application load balancer that we created within the EC2 instances, this is the application load balancer for CPE, and this is the DNS name that was created. And so let's go ahead and access CPE. And let's take a look at our current configuration. So I already created a P8 domain, and of course I have created two object stores. So let's take a look at one of them. In this object store, I have created two storage devices that will leverage the storage available within AWS. The first one is a storage device that is attached to the Elastic File System that we saw created within AWS. The second one is the S3 object storage that we also created within AWS and is configured for this object store. As you can see here is the connection URL for the S3 bucket that I'm using. So now let's go ahead and deploy Navigator so that way we can actually get an end-to-end scenario. And let me go back to the deployment. And so there are two ways that we can deploy. We can deploy it through the dashboard, or we can deploy it through the CLI. So let's go ahead and do what is pretty native from a Kubernetes perspective and deploy it from the CLI. So if we refresh this, we should see that there is a Navigator deployment that is currently happening. And again, in my deployment descriptor for Navigator, I have also specified two pods or two replicas so that we have HA. So we can see that it is starting to run, and it's not fully started yet, so we'll just give it a couple minutes for it to spin up. And then of course we can also go to the command line so it looks like all our nodes are up and running. So if we refresh, they are showing in a running state. So now if we go back to our load balancer, let's go get the DNS name for our Navigator load balancer. So here is our DNS name for our load balancer. And let's create another tab. All right, so we can see here, Navigator is up and running. Let's go ahead and log in. So let's go ahead and create a document that adds the document to our S3 bucket. And so I have created a doc class that is tied to that S3 storage device. Let me go ahead and add the document. Okay, I've added the document. And I also configured thumbnails, and so we should see that document. But let's go back to our S3 bucket to let's see if it actually got into there. So originally, we had roughly about 3 different documents that are stored in the S3 bucket. Let's go ahead and refresh this. We should see 4. And there is 4 that corresponds to this date that we just created. That concludes this demo of FileNet Content Services container running in AWS.